iOS web that is in beta right now, and desktop too that includes Linux, Mac, and Windows. Those are in technical preview right now. If you go ahead and change to developmental channel, you'll be able to implement the web version uh, of your app as well. And if you go to master channel of Flutter, right, you'll be able to do the desktop applications as well. Now, talking about the developmental part, right? Why would anyone choose Flutter? The reason is it is easy to develop the apps in Flutter, right? You don't have to learn Java for Android and Swift for iOS to do that. Again, the hot reload feature and the easy to add and stack widgets one on top of each other makes it very easy to use the UI part, right? You can, for example, write the code of this application in your main file. You can compile the app, you can delete the entire code, copy paste the code for an entire other app. And if you go ahead and, as long as you don't add or remove any package dependency, and you add the code of a fully different app and you just hit control and slash, it will recompile within seconds without closing the actual application. So that hot reload feature, that is present in Android and iOS Swift, but Flutter takes it to a whole different level. You can, if you are connected to web and multiple devices that you are prototyping, you'll be able to ship out code and control that reload feature within each and every device that you want. Now, since we're talking about cross-platform, right? There are many other solutions like React Native or Cordova that offer us this kind of hibernate and cross-platform kind of solution, right? What makes Flutter separate is, for example, if you take React Native, what they do is they have kind of their Java to native bridge, which what that will do is whatever we have defined in the code, right? For example, I've defined this back button, the title bar, and this options here, right, in React Native. So what it will do is it will then compile each and every code into the native controls of that particular platform. So for example, if it is iOS, it will compile for iOS, and if it is Android, it will compile this all this buttons and everything for Android, right? So if you go ahead and open and run your app in iOS and Android, both will look different, because iOS might have this kind of back button. In Android, we have this arrow kind of back button, and also the physics and navigation between the different screens will be applied as native for both platforms. That is a huge difference between React Native. While in Flutter, right, the widgets that we are getting, the buttons or icons or the basic widgets that we are getting, that we can implement from either the material library or the Cupertino library. Whatever we have defined, right, it will be the same. It will look the same in Android or iOS, no matter what platform you are using, because the code that we are writing in Flutter, the widgets that we are declaring in Flutter, as long as we have not defined the conditions of separate platforms, will use look and feel the same. So this can be beneficial if, for example, if we are shipping an app that has a unique brand language or design language, does not, for example, follow material or doesn't follow Cupertino style, but we want to give it a whole new look from the scratch. In Flutter, it is very easy, because we know that if it looks like this on Android, it will look like the same thing on iOS, right? And since we can stack and replicate the widgets one on top of each other as much as we want, we'll be able to define and make new controls and widgets in no time, and very easily, right? One thing in Flutter, right? Since I said that most of the widgets that we get are same, but you might not feel each and everything is same. For example, if there is a long list, right, then if you scroll on Android, right, it will get that kind of shaded glow that we get on Android devices, while in iOS it will get that bouncing action. So in the navigation phase of this, they've opted in for platform specific. But if we are talking only about UI and looks, right, it follows the same one widget or one application or one UI for all the platforms thing. Now, you may ask that what if you want to an iOS app to feel like iOS and Android to feel like Android? What if you want this button in iOS, this one in Android, right? So in that case too, what we can do is we can add in permission conditions, sorry, for each and every platform. We can say using the ternary operator that we discussed ago, right? We can say that if it is the platform is iOS, just show this icon, or if it is Android, just show this icon. Now in that case, right, if we are developing a huge application that we want to make it feel like a native, right, in Material and Cupertino in both the platforms respectively, in that case it may be a pain, to litter the whole code with if statements and conditional statements for the platform thing. In that case, we can again use a class to do that, but that can be kind of challenging if we are doing a native, not native, but native looking app, which is huge. So that is something you need to keep in mind before you start Flutter. Um, Another important
Could you
information.
could you
Yeah.
repeat the last point? And just for a second, I wanted to make sure. I mean, with eCorp, are we supposed to keep it an hour or 60 minutes? I
Oh,
don't know, like sharp.
yeah. So um, what we can do is we can maybe complete this kind of architecture that we wanted to discuss. Will keep it will take 15 minutes or so. So if you are available right now, we can complete this in the next
I,
15 minutes.
I am, but I'm just making sure with eCorp.
Yeah,
My first
one
day, so I don't know.
yeah, no, 1 hour is kind of ideal for eCorp, but I want to get over with the architecture today itself. So
Okay.
huh. So the last thing that I was saying is, for example, we have two apps, right? And if we are writing in Flutter, the both of those apps will look exactly the same. Now, if you are an iOS user, you might expect the back button to be in a certain way. You might expect the loading dialog box or the pop-up alert dialog box in the certain way. If you write in Flutter, right, you may not get that, native approach or the native look. So in that case, you might have to, write conditional statements. For example, in this icon, if I want an icon like this on iOS, I'll have to say wherever the UI of that icon is defined that, show me this icon if it is on iOS or this icon if it is for Android. So if we have to do this very same thing for each and every widget that we have, then it can be hectic, right? So that is one of the things that we need to see or take into the consideration when before we start Flutter. Can
So,
you hold?
but yeah,
Yeah,
okay.
just a
Hello,
second.
I have a question.
Yeah, your question.
Yeah, but like for real world apps, say I wanted to build an app that was going to be used by real world customers,
Hmm.
and it needs to work like the other apps do. It's a professional app, right? So
Hmm.
won't I have to do that native ended coding on those kind of apps?
So that is a great question. Yeah, so I also feel that the customers or the user will expect a native looking app, right? Again, that could be a good or a bad thing depending on the applications, right? Last few years or so, I've been seeing more and more apps taking a kind of their own approach, brand wise. For example, if you see Spotify, right? So it doesn't have any defined material or Cupertino design guidelines that it follows, right? It has its own kind of design language versus if you see WhatsApp, right? So it follows a native approach in which if you grab like have a look at a WhatsApp app that is running on Android versus a WhatsApp app that is running on iOS, right? Those have huge dissimilarities according to their UI. So that kind of decision lies in the kind of the app that we want to ship, right? And yes, if it is an app that needs a native fill, in that case in Flutter it could be harder to do than React Native. But again, in that case, it would always be easier than developing two apps in native.
Right. So how much percentage of the native code have you seen being written in Flutter? Like 5%, 10%, 50%?
Yeah, so again, that is a great question. In Flutter's keynote, Google kept saying that 90% of the code should be, common, right? And in my personal experience, right, what we, as I said, that most of our apps are defined as, the brands defined guidelines, and we do kind of unique designs, and that is similar in iOS and Android. So most like 95% of the code is same for us, right? Now, whenever we have to go and build a um what we say platform dependent thing, for example, if I want to use Bluetooth in a certain way, or if I want to execute long running background applications that may not be done in iOS but can be done in Android, in that case, right, I'll have to define my own um, um native code in Android and then use platform channels to ship it to Flutter. In that case, the percentage of the unique code that you write would increase, but I don't think it should get below 70%. Again, if you want to ship out the apps that look and feel native, right? I think that only a small percent of widgets will have to see that could have different different design guidelines, like the back button here. If you go ahead and see the, like, most of the application in this kind of window is with the text and the image. Most of it is text and image itself, so the cards and everything, those are the things that are that are included in that 70% of the majority portion of the code that is common. Also, the network calls and that all the model and logic stuff that we'll do, that will be hands down common code. So, like, again, it depends on the decisions that you are using making as a business to make it worth make Flutter worth using. It could be anywhere between better than native developing to not so much better or as much better as React Native, right? So it is all dependent stuff, but in any case, I think that the developmental time and effort that we spend would be always be better in than native.
Okay.
Okay, one more thing that I want to the last thing I two last things that I want to cover up is stateful and stateless widgets and the architecture of Flutter. So I'll quickly run you through that. In Flutter, I'll just grab this. Can I? Yeah.
Can you make sure that document that you share with ECOP that they're gonna share with me, it has these links so I can read them like in my
Yeah.
downtime if I want to?
Yeah, I'll just ping them after the call. So they'll be sending you the link for the same. And
All
again,
right,
if you
perfect.
want to, have a look at this, we just visit flutter.dev/docs. This is by far the best documentation that I've found. Again, we'll be sending those links. Um, Talking about widgets, right? What are widgets? In Flutter, everything you see is a widget, right? Starting from the controls, the buttons, the icons, right? The entire app is a widget, right? This entire app is a material widget. So widgets are kind of a control that are stacked onto different or more controls to form or to return a app. This kind of widgets are defined under a build method, right? That you'll see after we do the first application of Flutter. Widgets are defined as two types. First is stateful widgets, and the other is stateless widgets, right? In stateful widgets, right, there comes widgets which change during the course of running the application. That may be switches, right? If you have seen this, I don't think if it is here, but those kind of switches that you tap that turn off and on. It can be check boxes, it may be radio buttons. These are the widgets that preserve their own state, that have their own data saved in itself, that yes, I am either on or I'm off. And there are other widgets that are stateless. This can be buttons, right? Don't change, the UI of buttons don't change. This can be let's say image, right? Once loaded they might not change, right? There can be other things like title bar, text, right? They don't change. So we can define an app by combination of stateful and stateless widget. We can theoretically make the whole app with stateful widgets, right? But it won't be very much economical, and we might not be able to get that advertised 60 frames per second in our application at all the times. So stateless widgets are just there. So yeah, each and every time something app happens inside your app, right, the entire screen is redrawn. For example, if it is loading, right, and new data comes up, the entire screen is redrawn, including the icons, the back button, the title, the things that don't even change when those are redrawn, right? And that is done in 60 frames per second. So that is the reason we have included stateless widgets. So we won't it won't take as much time as stateful widgets take while loading or repainting, right? And this style of coding is known as reactive coding, that React Native also follows. Now, bringing you on to the architecture of Flutter, this is important because this might help you in the future if you are making scalable applications. If you have a great understanding of how Flutter works, right, it may help you to make an application that is perfect and highly performative, even if in the worst kind of situations. So if you have a look at the architecture of the SDK, right, Flutter is a framework that runs on the programming language Dart. So on the topmost stack, we have Material and Cupertino. Those are the widgets or the desired guidelines. Design guidelines out of Flutter and set of widgets in Flutter that are returned when we import this, both of the libraries respectively, that return us or make available the buttons or the checkboxes and the controls that are for Material or the Cupertino styled layouts. So all the widgets that we get are from the these two libraries. Then we have widgets that are again common for that are returned by this two, and there is rendering engine which lie below the widgets. As I talked about that each and every time something happens, we have to redraw the canvas, right? So that is where rendering comes into picture. So what is rendered, right? Animations that are rendered on the screen, the painting, all the widgets are kind of painted. So if you see Flutter, right, if you see native, the different controls are placed on the screen, right? In Flutter, what happens is the whole screen is a canvas, and once you start defining different widgets, right, stacking one on top of each other and defining the widgets, that kind of canvas is getting painted, right, with the library or the engine called Skia that is written in C or C++, right? Skia, since it is a low level, library used for painting canvases, it is highly performative. So it takes no time to, repaint the, the queue of, or sorry, the stack of entire widgets that we have to do. And the rendering, especially then, is very fast. This is one of the design implementations that Flutter has made that sets it apart. And then below that we have the foundation set of libraries. In rendering engine, right, we have this different things: asset resolution, system events, rendering, composition. You can dive into this if you want, to get a better understanding how isolates work and how threading works in Flutter. Sorry. And we have different platform specific things at the lower level. So that was kind of a overview of the architecture of Flutter, right?
Which
And
part of this do I need to know, like to make apps? I mean, is this just theory or interview questions or, selling Flutter, or do I need to know? I mean, I understand the framework, but do I need to know the engine and embedder parts
yeah,
also?
so that is again a great question for those kind of things, right? For example, if you are preparing for an interview, right? Hands down, just go through them, right? There are several Medium articles and even GitHub repos that show you the most frequently asked interview questions. In that case, right, if you are interviewing, the most common questions that you would ask is from here itself. So yes, this is important from interview point of view. They might not go in very details like what is Dart virtual machine or isolates. They may or may not. Again, you might find all this information by just Googling in the interview side of things. Now, in programming language, right, you can just start and start developing in Flutter without even having a look at this chart, right? But why is this nice to have, right? Is when, for example, you are actually making very huge applications that have to be scalable, right? You're not getting those 60 frames per second, or your app might not be performative. In that case, if you have a look at this, and if you know how the engine, Flutter engine works inside of code, right, then in that case you might be able to use many better programming techniques so that your whole app might be so much better performative if you are writing production code. For example, if for let's say we loaded a list, right, for this 100 items, right? Just imagine this list is not a set of integers, but they are a set of videos, right? We are not even videos, let's make it pictures, right? Like exactly like in a YouTube app, right? So in that case, if we are loading a list of 100 images, right, that can be like performance enduring, or that could bottleneck the performance. In that case, again, the list view that Flutter gives, it has this kind of lazy loading in which only the images or the the parts that are on the screen itself, only those are loaded and not the rest of those 100 are. But for example, just imagine that this 100 images are constantly loading, and they get on updating as live kind of data that is fetched from backend. In that case, each and every time a new data comes, the whole 100 kind of cells will get updated. In that case, the performance will get bottlenecked very much. So if you are able to, if you know how this painting and everything works, if you know that each and every frame is rendered at a like at a particular event, in that case you might be able to say that, oh, like I can restrict the loading for the last 90 widgets while these are loaded, or you can define a method or a class that only updates that particular images and not the rest 90 or 95 ones. So that is the reason this kind of architecture is nice to learn. For from the developmental perspective, it doesn't kind of matter for the most part if you get this by heart or not. Even many of the syntax you'll get for something like feature builder stream that you might, or even drop down buttons are there are very much common, but the syntax of that might leave you in leave you remembering that what was said. So it is fine that you don't have this by heart, but it is just nice to know. Now, talking about interviews and performance, right? I just wanted to you to see the Flutter Europe sessions that we had in 2019 or this year. I'm not sure. The net is slow. I'll say. So these are this is 2 months ago, yeah, so this is very relevant. So Flutter Europe happened 2 or 3 months ago, and this is kind of a keynote given by the Flutter team in regards to performance, UI, how do we implement complex UI. So these are 1, 2, and 3 videos that I've found is very much helpful, and they dive in so much deep on how the actual widgets are rendered, what happens to the tree, and how the tree shaking happens when widget at the end of the tree or at the parent of the tree gets updated. So if you have a look at these videos, you'll get a very much better understanding of how the Flutter engine works, right? So you can take this as a kind of assignment. Just search Flutter Europe and see these videos from the Flutter Europe channel.
Okay, I'll watch them today.